Hello everyone, welcome back again. So let's see some basic logical equivalences of two statement. So as we said that two statement, if they create the same truth table for the same combination, they are known as logical equivalent statement. So there are some property, there are some basic logical equivalences. By using them, actually, we can also use those property to statement, and we can prove that two statements are logically equivalent. So some basic logical equivalent statements are here. So the commutative property of two statement, we can see that P or Q P or Q is same as Q or P. So here, as a logically equivalent symbol, we can use the logical equivalent symbol. Sometimes we can use this symbol, or also we can use this symbol. Okay, so don't be confused with this one and this one. This one means double implication. Okay, double implication, and this one means actually logical equivalence. So here it is saying that P or Q same as Q or P. So it doesn't matter the order. So if you are saying that Trevor is unicorn or Trevor is goldfish, that's actually same as saying Trevor is goldfish or Trevor is unicorn. Okay, so same for and operator conjunction, like P and Q is same as saying Q and P. All right, then associative property says that if we have multiple more statement, looks like this: P or Q or C. Okay, so P or Q or C here, by the parenthesis we are going to see that we are going to evaluate this first, then we are going to evaluate this result with C. Okay, and this is going to give us the same truth table like P and this is going to give us the same truth table with P or Q or C. Okay, so same for and statement conjunction. P and Q and C will be same as P and Q and C. So this is known as associative property. So distributive property means we can actually distribute one statement with another statement. So let's see, we have P or Q and C. So this will be same as P or Q and P or C. Okay, so or P and Q or C, so it will be same as P and Q or P and C. Okay, so what you can do, actually you can actually come up with some example of a statement, and you can create a sentence, create a real statement like this, and you can find out whether they mean the same. All right, so here these are two interesting property known as identity property. So any statement, if you do a or statement with false, this is going to give you the same statement. All right, so for example, let's see, if we consider the truth table. If we consider the truth table, like we know that, say if one of the statement is false, if one of the statement is true, or is going to give you true. So if you have true, and if we are going to do or with false, so this will give you true, this will give you false. So you can see that the result is same as the statement P. Okay, so let's see, this is your statement P, and you are doing or with false. Okay, so the value of the result of truth table depends on the value of P. So if P is true, it will be true. If P is false, it will be false when you are going to do the or with false. Okay, and for and in and, if one of the statement is true, it is, if both of the statement is true, it is going to give you true. All right, now for and operator, the truth table, if you look at that, let's see, P, true and false, and we are going to do or with true. Okay, so the result will be same as true. True, true, it will be true. false true, it will be false. So you can see that P and true, it will be same as true. Okay, so if P is true, it will be true. If P is false, it will be false. So this is known as identity property, because this will give you the same statement. All right, if you do false with if you do or with a false statement, you will get the same statement back. Okay, if you do and with a true statement, you will get the same statement result back. Now the complement property means that if you do or with not P, it will give you 1, or means it will give you true. Okay, so here 1 means true, 0 means false. All right, so think about that, P or not P, P or not P. We know that or means either one of them has to be true. So if P is true, not P will be false. Okay, if P is false, not P will be true. So either any of them is going to be true. For example, I am saying that I am dead or I am alive. Okay, I know that either any one of them is going to be true. Either I am dead or I am alive. So one of them has to be always true. So it will be true. Okay, but for AND operator, if we are going to do AND with P and not P, it will be always false, because one of them is going to be always false. So in the AND operator, if both are true, it will be true. Okay, but if we are going to do P and not P, one of them has to be always false, so it will be false. Okay, so this result is always true, this result is always false. Okay, so these are some basic logical equivalences. We can use them also to find out whether two other statements are logically equivalent or not. So finally we have we can see these two properties, they are known as De Morgan's law. So we saw them actually in our last segment also. So if we have not P or Q, this is logically equivalent, saying that not P and not Q, or not P and Q is logically equivalent as not P or not Q. Okay,